Writing equations of lines. We're going to start with our y equals mx plus b form. This is called slope-intercept form because m represents the slope and b represents the y-intercept. Slope-intercept form shows us the slope and the intercept, and it makes it easy to correlate our equation to the slope and the y-intercept. For example, if we have negative 2x plus y equals 6. To put this into slope-intercept form, we need to move our 2x to the other side. We can do that by adding 2x. This gives us y equals, the x term comes first, and then the constant term. So let's go ahead and put the 2x first. Comparing this to this, the 2 takes the place of the m. So in this equation, our slope is 2. Or we can write that as 2 over 1, because then we can see the rise and the run. The b is the 6. So that's our y-intercept. Now remember, the y-intercept is where you have 0 for x, and then you have the value on the y-axis. So if we are graphing this, that means we start with our y-intercept. Our y-intercept is where x is 0 and y is 6. So x is 0 right here, and y is 1, 2, 3, 4, 5, 6. Then we use our slope to get to the next point. So from here, our rise is 2, so we go up 2, and we always run to the right, so over 1. Up 2, over 1. Up 2, over 1. Connecting our dots will give us the graph of our line. Let's try again. Number 2. Negative 2x equals 3y plus 6. I need y by itself, so I need to move this 6. The 3y is positive, so I'm going to leave y on this side and move 6 away. To move the 6, we need to subtract 6 from both sides. So we have negative 2x minus 6 equals 3y. Then we can divide everything by the 3. Now be careful. When you divide by 3, you have to divide every single piece by 3. So even though negative 2 over 3 does not divide nicely, you have to have that division piece. Negative 6 divided by 3 is negative 2, and then we're left with y. If you don't like looking at the y over here, you can switch it over, and then it will match what we have in our slope-intercept form. So looking at this one, the number in front of the x is our slope, and that's negative 2/3. We have a fraction here, but that's okay, because now we have our rise and our run to consider when we go to plot our points. Our y-intercept is negative 2, so that's when x is 0 and y is negative 2. So if we plot our y-intercept, x is 0, y is negative 2 is right here. And then this says we go down 2 in the negative direction for our rise. And we always run to the right. So down 2 and over 3. Down 2 and over 3. We can connect our dots. And then we have the graph of our line. Let's try again. Look at y equals 2/3 x minus 4. So in this case, our slope, our number in front of the x, is 2/3. And our y-intercept, 0, negative 4, from right here. See how it was plus b? So see how this is minus 4? So it's negative 4. So that means we start our graph at negative 4, negative 1, 2, 3, 4. And this says we go up 2 and over 3. It's a positive 2 this time. So we go up 2, 1, 2, and over 3. Up 2 and over 3. We can connect our dots There we go. And now we have the graph of our line. Let's try again. Next one says y equals negative 2x plus 5. So our slope in this case, the number in front of the x, is negative 2. I always like to have the rise and the run, so I'm going to go ahead and put that over 1. And the y-intercept, we have 0. From right here, we have 5. So we start with that y-intercept of 0, 5. 1, 2, 3, 4, 5. And we go down 2 over 1. Down 2 over 1. We can connect our dots. And then we have the graph of our line. Let's try again. This time we have to do a little bit of rearranging before we can find our slope and our y-intercept. So if we do a little bit of rearranging, let's move our 3x over by subtracting 3x from both sides. And then we can divide everything by 4. Now remember, when you divide by 4, you have to divide every single piece. So we have y equals negative 3/4 x plus 1. So that means our slope this time is negative 3 over 4. That's what's right in front of x. And our y-intercept is 0, 1. So we start with our y-intercept of 0, 1, which is right here. And to get to our next point, we go down 3 and to the right 4. So from 0, 1, we go down 1, 2, 3, and over 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. We can connect our dots. And now we have the graph of our line. Let's look at something a little bit different. Let's say that you are given a slope of negative 2, and you want to write the equation of a line that passes through the point 3, 4. To do this, we need to use what is called point-slope form. Point-slope form is a special form of our equation that lets us use a point and a slope to rewrite our equation. It looks like y minus y1 equals m times x minus x1. The way this works is you are given some information and then you're solving for some information. Notice here you are given x and you're given y of 1 point. So that means we have x1, in this case is 3, and we have y1, in this case is 4. You're given m is negative 2. So let's fill in everything that we know. We have y minus y1. Well, y1 is the y coordinate from our 1 point. In this case, that's 4. M is our slope, which in this case we're told is negative 2. X, just keep as x, minus x1. x1 is the 1x from our 1 point, which in this case is 3. Now, in order to get this into point-slope or slope-intercept form, we need to do some rearranging. First, let's distribute here. If you were asked to leave it in point-slope form, this would be finished. If you are trying to move it to slope-intercept form, then you need it to be y equals. So this right here is finished for point-slope. Let's go to slope-intercept just so you can see how they're related. If we distribute that negative 2, we have y minus 4 equals negative 2x plus 6. Adding 4 to both sides will give us y equals negative 2x. 6 plus 4 is 10. So these are the same equation. It's just two different forms of the same equation. It'll be the same line on the graph. This one is point-slope form. this one is slope-intercept form. And it will just depend on which form you're asked as to which equation you would leave it. Let's try again. Let's say you're given 2 points this time. So 1, 2, and 5, 6. Well, point-slope form only uses 1 point, so we can't do that. Slope-intercept form uses a slope and an intercept, so we can't do that. So before we can directly use one of our equations, we need to use what we're given and figure out some more information. We have 2 points, so we have x1, we have y1, we have x2, we have y2. So let's go ahead and find the slope, and then we'll be able to use 1 point and our slope. So remember, our slope is y2 minus y1 over x2 minus x1. So let's fill in what we know. Our slope is y2, so in this case that's 6, minus y1, which in this case is 2, all over x2, which in this case is 5, minus x1, in this case is 1. 6 minus 2, that gives us 4. 5 minus 1, that gives us 4, which means our slope is 1. Or we can do 1 over 1 if you were going to graph it. So our slope is 1. Now we can use our point-slope form because we have a point. In this case, we have 2 of them. And we have a slope. Now for point-slope form, it does not matter which of these 2 points you use. We just need the x-coordinate from one of our points and the y-coordinate from that same point. We already have them labeled x1 and y1, so how about we just go ahead and use that one, because then it can go directly into our formula with what we already have for our labels. But you could use the 5, 6. All that matters is you use the x and y from the same point when you put it in here. So we get y minus y1 we had labeled as 2. M we have found to be 1. x1 we have labeled as 1. Distributing that 1, we get y minus 2 equals x minus 1. Moving the 2 over by adding, we get y equals x plus 1. If you had used the 5, 6, when you put it into slope-intercept form, you still would have x plus 1 as your result. Let me show you. So we have y minus, in this case the y would have been 6, still m of 1, x minus 5. So we have y minus 6 equals x minus 5. Adding the 6 to both sides, that's why it doesn't matter which point you use from here, as long as you're using a consistent point where you're picking the x and the y from that same point. When we looked at section 2, we briefly looked at horizontal and vertical lines. So let's go back over that really quickly to make sure that everyone remembers. If you are given the point 5, negative 3, and you are asked for a horizontal line that passes through this point, what would that be? A horizontal line that goes this way. So that means that no matter what x you're using, the y is going to stay the same. So y will stay negative 3. If you're asked for a vertical line, well, a vertical line goes this way, so no matter what y is going to be, x will stay 5. So for our point 5, negative 3, the equation of a horizontal line would be y equals negative 3, and an equation of a vertical line passing through that point would be x equals 5. Let's do a little bit of review of parallel and perpendicular. So say that you are given the point negative 1, 6, and you want to create the equation of a line parallel to 4x minus 2y equals 6. Well, for the lines to be parallel, that means they have to have the same slope. So we need to figure out the slope of this equation. Minus 2y, that's negative. So I'm going to go ahead and put that on this side. So then we have 4x equals 6 plus 2y. Move the 6 over by subtracting. Divide everything by 2. If you don't like the y on that side, you can move it over. And now we have slope-intercept form. The slope in this one is 2. Now we want the parallel. So the symbol for parallel is two short parallel lines. So slope, parallel, see those two little parallel lines right there? Parallel means the same slope. So 2 or 2 over 1. I need go through this point parallel to this. So we can use our point slope form. So substituting in our points, y1 would be 6. Our slope is 2. Our x minus x1, well, x1 in this case is negative 1. So minus negative 1 is going to become, add the opposite, so positive. If you wanted to leave it in point slope form, this would be finished. If you need to move it to slope intercept form, we would distribute our 2. And then add 6 to both sides. So again, these are the same line, and either of these is accurate depending on what you're asked. If you're asked to leave in point slope form, you would leave it like this. If you're asked for slope intercept form, you would leave it like this. Now let's use the same question, but instead of parallel, let's look at perpendicular. So let me get down to here. So if we're looking for perpendicular, perpendicular looks like a little upside down T for its symbol. So this is going to mean the perpendicular slope. The perpendicular slope is the opposite reciprocal. There we go. So the opposite reciprocal means we switch the sign. So I had a positive 2 here, so now it's going to be negative. And then you flip this over. It was 2 over 1, so 1 over 2. And then we can substitute everything in. Y minus our y is still 6. Negative 1/2 is our new slope. X minus negative 1 will become plus 1. If you're asked for point slope form, that's finished. If you're asked for slope intercept form, you can distribute and simplify down. We're going to add that 6 to both sides. And then if we have negative 1/2 plus 6, that's like negative 1/2 plus 12 halves. So that's 11 halves.